Okay, so this is just a very, very quick video to show for students who are absent for this lesson on how to use mole ratios to solve questions. The first thing you need to understand is that a balanced chemical reaction is it's just a mole ratio. So when we see this reaction that says 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia, this is literally telling you exactly what's going on in the equation. But notice that this 1 mole of nitrogen reacting with 3 moles of ammonia, or sorry, excuse me, with 3 moles of hydrogen and 2 moles of ammonia, it's a ratio. It is a 1 to 3 to 2 ratio in that same order. But when we solve problems, we don't want to have to deal with all 3 of those ratios at once, so we'll deal with 2 of them at the same time. Right? So remember that all reactants get used up. So during the reaction, these are going to be going down. They're going to be used up, and they're going to form the products. Okay? Some chemical reactions are reversible, and the reverse will be true, but generally we're going to keep to that general theme for simplicity. Okay? So, knowing that, we basically have a bunch of ratios here. I can compare hydrogen and nitrogen, and you can see that 1 mole of nitrogen reacts with 3 moles of hydrogen, and I can write it nitrogen on top, hydrogen on bottom, or hydrogen on bottom and nitrogen on bottom. I think I said that backwards, but I think hopefully you get the idea. Those two things are essentially, they are equivalent. They are the same thing. It is the same to say 1 mole of nitrogen reacts with 3 moles of hydrogen as it is to say 3 moles of hydrogen reacts with 1 mole of nitrogen. They are saying the same exact thing. I can do the same ideas with ammonia and hydrogen. So here's ammonia and hydrogen. And notice my numbers. 3 moles of hydrogen react with 2 moles of ammonia. Or 2 moles of ammonia react with 3 moles of hydrogen. It's the same thing either way. So take a moment and look at the chemical equation and try and put in the correct numbers for the relationship between nitrogen and ammonia. Pause the video and try that. Okay, hopefully you paused it. All you need to do is you just need to look at the equation. So for my moles of NH3, well, that means 2 moles of NH3. So I'm going to put a 2 in front of the NH3 and that invisible 1 in front of nitrogen. Or I could do 1 in front of nitrogen and 2 in front of ammonia. And I'm going to see that the relationship between nitrogen and ammonia is 1 to 2 or 2 to 1, depending on which order that you put it in. But it is the same ratio either way. We're going to use that ratio to solve questions just like we did with molar mass and cancel our units. So we might get a question like this. How many moles of nitrogen are needed to completely consume 12.8 moles of hydrogen? Well, notice this isn't, we're asking for this, but we're saying we're going to use 12.8 moles of that. We're not using 3, we're using more than 3. So we're just finding the same ratio, that 1 to 3 ratio here, but for nitrogen, because I need 1 mole of nitrogen for every 3 moles of hydrogen. Do not make the mistake of ever saying it's 1 gram of nitrogen to 3 moles of hydrogen. That is going to cause you a problem. It is always moles. It is number. Remember, when we balance these, it's about the number of molecules or atoms, not about the mass, although the mass is going to be equal on both sides because of that. So here's what I'm going to do. I'm going to follow the same idea. First, in my head, I'm going to see that the relationship between hydrogen and nitrogen is a 3 to 1 ratio or a 1 to 3 ratio. But when I'm solving the question, I'm going to put in my given. So the given is 12.8 moles of hydrogen. So I'm going to write out 12.8 moles. And here, you definitely want to put the formula for hydrogen. I know it's H2 because that is what's in the equation. And I'm going to multiply that by a ratio to change my units. So this is literally exactly what we were doing before with molar mass. I'm going to put a little chart like this just to kind of help keep my work clean. And so on bottom, I want moles of H2 because that's going to allow me to cancel my units. And on top, I'm going to end up with moles of N2 because that's the relationship that I know between N2 and H2. I know the mole ratio. I do not know the mass ratio. We can figure that out for those of you who understand how to do it, but we're dealing with a mole ratio. So I have 1 mole of nitrogen to 3 moles of hydrogen. So notice, when I'm done, the unit that's left is moles of nitrogen. Later on, we'll do some problems where we have to deal with mass, and we have to change grams to moles and moles to grams, or moles to grams and grams to moles, and we're going to have to do that just like we did on our most recent quiz. But this is easy. So now I'm going to take in my calculator, and I'm going to type 12.8 times 1, I don't really need to do that, divided by 3, and you're going to get your answer. Do that in your calculator right now, pause the video, and see what you get. Make sure you round, in this case, round to 2 decimal places. And you should get, when you're done, 4.27. So it takes 4.27 moles of nitrogen to completely use up 12.8 moles of hydrogen. And this is my final answer for this question. Notice I didn't have to worry about ammonia at all for this question because the question didn't ask anything about it. Let's move on to another question. All right, same idea. We're going to find out how many moles of ammonia. Oh, look, so I'm looking for moles of ammonia this time that are produced if 12.8 moles of hydrogen are consumed. So this is really essentially the same question, but now instead of paying attention to the nitrogen, I'm paying attention to the hydrogen and the ammonia. You'll notice that the math doesn't care about which side of the equation these things are. It's all about the ratios that are there. So let's write out my given. My given, again, is 12.8 moles of hydrogen. Notice I'm not writing just 12.8 moles. I'm writing 12.8 moles of hydrogen. We need to keep track of our substances now because essentially what the mole ratio allows us to do is it allows us to change substances. So I'm going to multiply by a ratio to change units. So I have to think to myself, what do I want? Well, in the end, the question says, how many moles of ammonia? So when I'm done, I want moles of ammonia. Which one's ammonia? Remember, go back to the question, what it said. That's ammonia. So I'm going to want moles of NH3 when I'm done. That means I need to find a relationship that goes from moles of hydrogen to moles of ammonia. Oh, look, that's what the chemical reaction allows us to do. So 3 moles of hydrogen will react with 2 moles of ammonia. Notice I'm getting all of this work from the balanced chemical equation. My moles of hydrogen are going to cancel off. That's why I wrote the moles of hydrogen on bottom. I wanted moles of ammonia, so I wanted to put that on top. And now, in your calculator, before you see the answer, pause the video, do the calculator work, and make sure that you're doing the calculator work correct. So for my calculator, I'm going to do 12.8 times 2 divided by 3. If you do 12.8 divided by 3 times 2, it doesn't matter. PEMDAS tells us that we can actually do that in any order. But essentially, everything that's on top, I'm going to multiply, and everything that's in the denominators, I'm going to divide. So when I'm done with this, rounded to 3 sig figs, or to 2 decimal places in this case, I'm going to end up with 8.53. moles of ammonia. Again, what you're going to do is always take your given value from the question, and you're going to multiply by the ratio to change your units. Since we're trying to go from hydrogen to ammonia, I know that I need to use a balanced chemical equation, because the only way I can change hydrogen to ammonia is not by magic, but it's by some chemical reaction. I hope this video helps you. Please continue and try the questions on the mole ratio practice. This is set up so that you'll notice that the first one is done for you, so you can kind of check your work. And then as you go, you need to start filling in answers as you go. It is annoying, I understand, to write moles CH4, moles H2O. But if you don't do that, you're going to get confused as we get more and more complex. Get used to writing it. It takes a moment. For those of you who want extra time, here's a third question. I'm going to do this very quickly. Take a moment to try this on your own. And pause the video. All right, so once again, I'm going to look at what's given, what's fine. So my given is how many moles of hydrogen. So this time I'm looking for moles of hydrogen are needed to produce 18 moles of ammonia. So my given is what I have underlined in blue, and I'm looking for what's in red. So my thought process, write my units, moles of ammonia. I know I'm going to multiply by at least one thing. And what I want when I'm done is I want moles of hydrogen. So I need a relationship that will give me moles of hydrogen, since that's what I want, that's going to end up on top. And I want to get rid of moles of ammonia, because that's what's going to cancel it off. So moles of ammonia are here, moles of hydrogen are here. So that tells me 3 moles of hydrogen are going to produce 2 moles of ammonia. My calculator, I'm going to do 18 times 3 divided by 2. And you should get 27.0 moles of hydrogen. If you just said 27, it's the same value. Good luck. Hopefully this helps.